Hi, and welcome to the demonstration video for the StarPoint navigation system from Equinox Navigation Instruments. We appreciate your interest. StarPoint is a non-GPS based system that allows you to find yourself virtually anywhere on the planet. Using this system, as long as you can see the sun, you can put yourself on the globe. Traditional celestial navigation has long served this purpose, but it has often been a pretty daunting discipline, requiring considerable training and investment in time and equipment. Not the least of these is the sextant, an expensive, fragile, and bulky optical tool that requires regular maintenance and calibration. For some navigators, of course, this is part of the allure, but for many navigators, the most important thing is to have a straightforward and robust system that just works. The StarPoint system simplifies celestial navigation and eliminates the need for many of these traditional tools. It uses just a few simple and durable pieces of equipment to make 2 observations of the sun during a single day, and with information provided by the watch, allows you to calculate your position from anywhere on Earth. And unlike many traditional systems, it gives you your coordinates directly, without the need to plot yourself on a map. Let's dive in a little bit, and if you're an experienced navigator, some of this might be a review. Locations on Earth are in the form of coordinates. Each spot on Earth has a unique address based on the coordinate system of longitude and latitude. This system is pretty old. It was first established by the Greek geographer Eratosthenes in the 3rd century BC, but it is still in use today because it is so useful and intuitive. Longitude and latitude are closely tied to the movement of the celestial bodies across the sky. Longitude gives east-west coordinates and ranges from 0 up to 180 and then back down to 0. Latitude gives north-south coordinates and ranges from 0 to 90. For both the north and the south hemispheres. On the globe, there are a couple of important longitude and latitude lines. The first is the equator, which is the main reference line for latitude. The equator is latitude 0. Latitude coordinates start increasing north or south of that line. The second is the Greenwich meridian line, sometimes called the prime meridian. That line is longitude 0. And longitude numbers ascend either east or west away from that line. We can use celestial bodies to find our position with these coordinates. The StarPoint system is specifically calibrated to the sun's movement across the sky. The principles are pretty straightforward. The height of the sun in the sky can tell you your latitude. Light from the sun hits the Earth at a more direct angle closer to the equator, and at a more oblique angle further from the equator. The closer you are to the equator, the higher the sun gets when it moves across the sky. If you are closer to either of the poles, the sun is lower. If you can take a precise measurement of the sun at local noon, when it is at its highest point in the day, you can calculate your latitude. Longitude takes advantage of the fact that the Earth rotates once every 24 hours. That means that the sun moves across the sky 15 degrees an hour. For example, if the sun is at its peak where you are exactly 5 hours and 30 minutes after it crossed the Greenwich Observatory, you can calculate your position as 82.5 degrees west longitude. We have developed a new system, recently published in the Journal of Navigation, the official journal of the Royal Astronomical Observatory in Greenwich, England, that uses these 2 aspects of the sun to allow you to calculate your position. So how does this work? Well, the sun rises in the east and moves west across the sky. You take 2 observations, once as the sun ascends across a specific angle above the horizon, and then when it crosses that angle again descending. This looks like a straight line looking at the horizon, but when we lie flat back, the shapes change. Now we can see that it is on a curve parallel with the horizon. We use the timing of these 2 moments, plus the angle above the horizon of the observations to create a triangle. If you remember your high school trig, you know that if you have 2 sides at an angle, you can calculate the other angle. And that is exactly what this system does. In practice, you only need to take 2 observations over the day through the small glass tool called a brisk sextant that is part of the kit. We put ours on a lanyard so you can hang it around your neck and make quick observations. To take an observation, you hold it up to your eye and look at the horizon in the direction of the sun. Although the brisk sextant blocks out about 50% of the light, we have provided a welding shield on the lanyard to protect your eyes. Looking through, you see something like this. Each of those dots is a refractory image of the sun at a specifically measured angle below the sun. When one of the images aligns with the horizon, you now know the angular height of the sun above the horizon. You note down the reading of the watch at that moment. The watch is, with its red double hand, tracking the sun across the sky. The information is angular, matching the longitudinal coordinates. Here's how you read it. The double red hand tells you it is above 135 degrees. The minute hand tells you to add 2 degrees and 30 minutes to 135. The second hand tells you to add 9 minutes and 30 seconds. So now you have an angle. You collect that angular information twice, once when the sun is rising and again when it is descending. The brisk sextant has multiple angles, so you can take multiple readings over the day. Also, you can read regular civil time with the hour, minute, and second hand on the inner circle. It is 10, 11, and 38 seconds on this watch. And then you just plug that information in. You can do it by following the steps in the included booklet and solar calculator, and it will take you about 5 minutes to calculate your position. Or you can use the smartphone app. Note that the smartphone is not using its GPS. Instead, it is just a calculating device and will work even if a GPS signal is blocked. That's all there is to it. We even give you a mechanical pencil. The system can also be used at night if you know the angular difference between the sun and any star. This information is in any nautical or star almanac. Although most celestial navigation is done on the ocean, this method works just as well on land. You just use any piece of still water, such as a filled coffee cup, as a natural horizon, since water will always find its own level. All of the equipment comes stored in a compact Pelican waterproof case. The system includes the watch, a brisk sextant, a filter for bright sun, a Casio FX280 solar scientific calculator, a small compass for the watch band, a mechanical pencil, and the manual, complete with multiple worksheets and all information necessary to use the system. And if you don't like olive green, we offer a variety of bands to suit your style. Everything you need to find yourself anywhere on Earth is in the kit. All you need is to be able to see the sun. Thanks for watching the video, and we hope you enjoyed learning about the StarPoint navigation system.